And we'll see what this goes. Okay, it says it's been live for 30 seconds, which I don't understand. But anyway, so this is, I guess, potentially the first episode of the Swyx and Ben mixtape.
It's not as catchy as Mixtape, but I'll take it. Gotta have my name on the placard.
Yeah, I really needed this also because I was falling behind and I felt really guilty. But like, I think it's a good exercise. I just need a partner, you know. And so I'm hearing my audio come in on the wrong side of the. Okay, so is my audio better now? Because I just switched the microphone to my MacBook. Is that better?
It sounds the same to me, but it sounds good.
All right. As long as it sounds good, that's what we care about.
My exposure's super low. I'll need to figure that out for my Twitch stream later.
We'll figure out the Well, and you know, we're doing a few episodes today, so we'll just crank them out, and then there's the effect. Okay.
Beautiful.
So we're watching the Deconstruct 2020 talk from Dan Abramov about the wet code base, and I think we're starting from the timestamp of 10:30. So I have a bit of familiarity. I mean, we can sort of discuss this, right? Like, so both of us, this whole week we're doing API design, which is actually a interest of mine as well, which is why I kind of lit up when you suggested this. I do think like you by being a listener of the Swyx Mixtape, like you have opted into like a pretty strong set of interests that I have also. So I'm sure we can find a lot of mutual topics. And yes, you've also told me that there's some things that you're not interested in, which we can also skip. But this one, obviously, it's a thing that Dan has been working on for a long time, and he's just a very talented explainer of things. My context is that this is basically explaining Y hooks, and then also just like reflecting on his prior work on Overreacted, where he talks about the wet code base. Any other context before you want to set stuff?
I'd forgotten about his written blog, but yeah, it's that blog post pretty much adapted, which is nice.
It's this one, yeah, Goodbye Clean Code, and he was kind of talking about his past experience about how he wrote a bunch of really crappy looking code, right? That he repeated himself a lot of times, and then he was like, okay, let me dry this up, and then like look at how beautiful, look at all these abstractions, and then he found out that it was completely not fixable, right? Like he spent a bunch of time cleaning up the code and making it dry and making it look pretty, but then anytime he needed to change it, it would fall apart again, and he would have to dig through like 3 levels of abstraction just to do what he wanted, right? Whereas if it was just the very, very basic stuff, he could just add it to the right place and it would just work. So there's sometimes when abstraction is called for and sometimes when it's not. I think he had more to say about that, but we could just kind of watch it and then we'll discuss it later.
That sounds right. Yeah.
Sound good? All right. So 10:30 is the time you marked out, and now I'm just gonna play it at like 1.5x because.
Yeah.
Is the audio coming through okay?
I do not hear the video right now.
Oh boy. All right. So I need to play system audio. How do I do that? Yeah, I don't.
Well, it's not something that you can do from StreamYard. I've had to go through this before.
Oh God. Okay.
It's possible that I could screen share if
that changes something.
If that works. So I had to do something in my system for this, where I set up a multi-audio output. Yeah.
Oh, I have loopback.
Do you have that? Okay.
Okay.
All right. Yeah, I have the scrappy one that's open source. So.
No, I paid for the real thing.
Okay.
Okay. So for the media mavens in the room, loopback is where you join to audio sources. God. Updates. Software updates.
It's like when you try to brew install something and it spends the whole time updating homebrew. Yeah.
Am I back to
it's using a different audio source now.
It's using a different audio source, yes.
Okay.
So I'm just gonna do this. So now loopback, basically, I have this setting, right, that passes in my MacBook Pro mic and then my system audio.
Yeah, it's nice that it visualizes in this.
It's really nice. I just need to make sure I'm playing the system audio. Maybe if I just kind of do this, it's playing from Chrome. Okay.
Sure.
And then let me play this, and then let's see if that.
No, I don't hear it. I'm surprised. Okay.
I can't hear you. So. Because
but I can call the function call send email, and
now I hear it.
It works
okay,
most of the time, and it's really nice to be able to focus on it. And of course, another benefit is just being able to reuse code written by you or
can you hear it?
And not remember how it actually works. So if something is exactly the same thing that we already used from different places,
you said something.
It's very nice to be able to reuse it. So that's
perfect for me.
Abstraction.
I can hear it.
And abstraction also helps us avoid some bugs. So in the example where we have a bug in like we copy pasted something, and that's like an
great
copy paste this.
I can hear it too.
And then we found the bug.
Okay, so we can hear each other, and I can hear you.
Yes. That was fast.
Sorry for that. I've debugged this live a couple times.
Okay.
It's always annoying when it messes up.
Oh, for sure.
Okay, so let's watch this through till the end, you said?
Yes, that's what I marked down.
And you can pause me whenever, and then I'll just pause the video.
Sounds good.
We should try to explain what is it that you're actually trading away? What are the benefits and what are the costs of this idea? And so if we talk about the benefits of abstraction, of course it has benefits. Like all of the whole computer is like a huge stack of abstractions. And I think like concrete benefits are abstractions let you focus on a specific intent, right? So if you have this thing and you have to keep it all in your head, but it's actually really nice to be able to focus on a specific layer. Like maybe you have like several places of code where you send an email, and you don't want to like know how an email is. Like I don't know how emails are being sent. It's a mystery to me that they even like arrive. But I can call a function called send email, and well, it works most of the times. And it's really nice to be able to focus on it. And of course, another benefit is just being able to reuse code written by you or other people and not remember how it actually works. So if we need something exactly the same thing that we already used from different places, it's very nice to be able to reuse it. So that's a benefit of abstraction.
One thing I like about his presentation style is he uses very abstract.
Yeah, he diagrams most things.
Yeah, I think that keeps it simple, and yeah, I don't know. I just really like it. There's a maximum of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 words.
Words to a slide. Yeah. And he does the bare minimum detail you need to get something across. Like he'll change a circle to a square if he needs to explain square peg in a round hole, but he'll still just make it a circle. He's not going to detail it in some beautiful metaphor because it's enough if you can just show it.
Yeah. Okay.
And abstraction also helps us avoid some bugs. So in the example where we have a bug in, like maybe we copy pasted something, and that's like an argument against copy paste is we copy pasted something and then we found the bug in one version and we fix it. But then the other version stays broken because we forgot about the copy paste. So that's a good argument for why you'd want to extract something and pull it away. But when we talk about benefits, we should also talk about costs. And so one of these costs is that abstraction creates accidental coupling. And what I mean by that is, so we have these two modules using some abstraction, and then we realize that one of them has a bug, and we have to fix it in the abstraction because that's literally where the code is. But now it's your responsibility to consider all of the other call sides of this abstraction and whether your fix might have actually introduced a fix in another, introduced a bug in another part of the code base. So that's one cost. Like maybe you can live with it. Most of us live with it, but it's a real cost. And I think even like more dangerous cost is the extra indirection an abstraction can create. So what I mean by that is that the promise was that I would just be able to focus on this specific layer in my code and not actually care about all the layers. Like, is that really what happens? Because like I'm sure most of you probably had this kind of bug where you started one layer and you're like, oh, it goes here, and it's like, well, actually, no. It also like you need to understand this layer and this other layer because the bug is it goes across all of those layers.
Yeah. So this is the problem he was describing in the wet code base blog post.
Gotcha.
Yeah.
Yeah, and for those listening, big pyramid of circles leading up to other circles where you have a God abstraction and then everything kind of trickles down. Classic.
Yes. Yes.
We have a very limited stack in our heads. And so what happens is you just get a stack overflow, which is probably why the site was called that way. And so what I see happen a lot is that
I like that, sprinkle a little joke and get the audience to laugh, because sometimes it's a very serious and abstract talk. You need to break the tension a little bit.
Nah, totally.
we try so hard to avoid the spaghetti code that we create this lasagna code where there are so many layers that you don't know what's going on anymore at all. So that's extra indirection. And like all of them wouldn't be that bad if they didn't entrench themselves. So abstraction also creates inertia in your code base, and that's kind of a social factor more than technical. What like I've seen happen many times is you start with an abstraction that looks really promising and kind of makes sense to you, and then with time it gets more and more complex. But nobody really has time to refactor or like unwind this abstraction, especially if you're like a new person on the team. You might think that it would be easier to copy and paste it, but first you don't really know how to do that anymore because you're not familiar with that code. And second, you don't want to be the person who just suggests worst practices. Like, who wants to be the person who says, let's use copy paste here? Like, how long do you think you're going to be on that team? So you just accept the reality for what it is and keep doing it and hope that this code is not going to be your responsibility anymore soon. And the problem is that even if your team actually agrees that the abstraction is bad and it should be inlined, it might just be too late. So what might happen is that you're familiar with just this concrete usage, and you know how to test it. You can, like, if you unwind the abstraction, you can understand how to verify that the change didn't break anything. But maybe there's another team who uses it here, and another team who uses it there, and maybe this team has been reorged. So there is no team that maintains that code, and you don't really know how to test it anymore. So you just can't make that change even if you want to. So I really like this tweet. It's a bit hard to read. Easy to replace systems tend to get replaced with hard to replace systems, which is kind of like the Peters principle. There's this Peters principle that everybody in organization continues raising until they become incompetent, and then they can't raise anymore.
The actual quote is, everybody rises to the level of their incompetence, right? Because if they're competent, they get promoted. Competent get promoted until they're no longer competent.
Nice.
Do you know about the money version of this law?
I could see it, but yeah, what is the one that you know of?
I don't know the name of it, but it's basically good money drives out bad. So it's Gresham's law. So you can think about this in the age where coins were made out of like actual gold and silver, right? So you would have like a $1 coin that would be made out of some percentage of gold, right? And all it takes is just for somebody to make a similar looking coin with slightly less gold, and another one to make slightly less gold. And the people who would notice that would devise ways to figure out which coins have more gold and which coins have less, and they'll keep the ones with more gold and circulate the ones that have less gold, right? Just for example, by weighing it. So over time, less good money or bad money drives out circulation of the good money, because the good money just like stays put, and the bad money just like proliferates. So yeah, this is the actual law. This is the opposite, but that's Gresham's law. And so what Malta in that quote was stating was
go back to that one.
Code version of that law. I actually was very happy with this when I read it. Yeah, I think I may have quoted this in my book, actually. It's just so good. It's so good. There's a similar one, another similar one. I forget the name of it as well, but basically, like complex. There's simple systems only arise out of other simple systems. They cannot be built out of complex systems. Get the quote of that.
I kind of hear you. So when I hear like hard to replace, I think of business factors like vendor lock-in, and I also think of just developer factors of once you have enough abstractions, you can't maintain it well anymore. So is that quote kind of speaking to both? Is there an element of like pure greed in there, or is it just it's inevitable that systems get harder to replace because you try to add so many holes to it?
I don't think doesn't need to be a system of intent. There can be a system of intent. The joke that us developers make is job security, right? Like implement
exactly.
a wondrously complex thing that nobody else in the company understands, and obviously they'll have to keep you around to maintain it.
10x engineer. Yeah.
But I like this because the operation, which is replacing, is in the definition of the systems. Right? Whereas all the others are like talking about money replacing money, or complex systems replacing simpler systems. This is just straight up easy to replace definitionally. Will get replaced by hard to replace systems over time.
Yeah.
You can inspect this single sentence and it's true.
Yeah, that's true. I didn't even pick up on it will get replaced. That's literally
just throw
it's just
time
circular.
It's gonna happen.
It's gonna happen.
Yeah.
Replace systems, which is kind of like the Peter's principle. There's this Peter's principle that everybody in organization continues raising until they become incompetent, and then they can't raise anymore. Nobody understands how it works. So I'm not saying that you shouldn't create abstractions. That would be a very two-dimensional or one-dimensional takeaway. I'm saying that there are some things that we're going to make mistakes. So how can we actually try to mitigate or reduce the risks from those mistakes? And so one of them that I learned on the React team in particular is to test code that has concrete business value. So what I mean by that is, say we have this a little bit wonky abstraction, but like we finally got some time to write some proper tests because we fixed some bugs, and like we have a gap before like the new half of the year starts, and we can fix some things. So we want to write some unit test coverage for that part. And intuitively, where I would put unit tests is, well, here's the abstraction is where the complex code lies. So let's put unit tests to cover that code. And that's actually a bad idea, in my opinion, because what happens is that if later you decide that this abstraction was bad and you try to turn it into copy paste, well, guess what happens to your tests? They all fail. And now you're like, well, I guess I'll have to revert that because I don't want to rewrite all my tests, and I don't want to be the person who suggests to decrease the code coverage. So you don't do that. But if you have a time machine, you can go back and you can write your unit tests or integration tests or whatever you want to call them, fat of the day tests, against the code that you actually care about that this code works, against concrete features. And then these tests, they don't care about your abstraction. So you can inline the abstraction back. You can create 5 layers of abstraction. The test will tell you whether this code works. So actually, they will guide you to refactor it because they can tell you that your refactoring is, in fact, a correct one. So testing concrete code is a good strategy. Another one is just to restrain.
So do you know there's a real life example of what he's talking about here that he didn't mention?
Real life one that comes to mind?
This is where just studying Dan for the past 5 years makes me very qualified.
I see. Oh, React. I remember nothing about React Fiber. I know it existed, but it was a code name for which feature?
It was React 16.
Oh, interesting.
React was completely rewritten from 15 to 16. And the way they rewrote it is they wrote tests for the entire public surface area of React. And then they broke it. And then they made tests pass over the course of 1.5 years. So that's what he's talking about with with this test.
Yeah, because I know Astro tries to kind of adhere to that, but to a fault, where if you try to test more concrete code, you end up having to spin up more of the universe, where we just want to write unit tests. We want to unit test a really small utility function that does the thing and hope that covers everyone. But in order to test practical applications of Astro, you have to spin up a fixture that has an example of something you want to build. And you got to wait for CI to spin that up, build it, run through your test, and spin it back down. Yeah. So the one thing we're running into now is we want to test the more concrete code, but that means creating more of an environment, which slows down CI pipelines and everything else. So there's a cost to trying to test lower down the chain instead of higher up the chain. And we're still in a funny place. Yeah, Kent C. Dodds and many others have had opinions on that, where I do think integration tests are where things should live, and it's where all our stuff lives. But yeah, it's just a tooling problem for us right now, where we're trying to figure out the best way to integration test without spoofing so much that it's not even real. It's not even concrete.
Yeah. It's easy to draw diagrams, but the hard part is actually figuring out the implementation. So Kent's not the only one, for what it's worth, talking about the oddly shaped triangle test or whatever, Honeycomb or Spotify has also talked about it.
Mm.
Cool. And then for those interested in the fiber rewrite, I think Sophie Alpert also wrote about it.
Oh, nice.
This is how much I know about React.
Yeah. Keep asking these leading questions on history. I'm like, I thought I had a good idea of React's progression, but no,
I know way too much, man.
I have a big gap going back to React 16. I know way too much about the server component history.
Yeah.
Got a 4-hour stream on that, but I have to get into that from Dan himself.
Yeah, that's the new hotness.
Yep.
So, all right. Those want to know the full story. This was written in 2017 about the compatible rewrite, and it talked about the test strategy, which is exactly what Dan is referencing here, but he didn't talk about React at all because I think he wanted this to be more general.
Yeah, evergreen.
How that this code works against complete features. And then these tests, they don't care about your abstraction. So you can inline the abstraction back. You can create 5 layers of abstraction. The test will tell you whether this code works. So actually, they will guide you to refactor it because they can tell you that your refactoring is, in fact, a correct one. So testing complete code is a good strategy. Another one is just to restrain yourself. Like, you see this pull request, you get this itch, like, oh, this looks duplicated. And you're like, nah, take a walk. Because, like, if you have this, like you might have like a high school crush, and they are really into the same obscure bands on Last.fm that you're into. That doesn't mean that you have a lot in common. And they're going to be like,
that's my favorite quote.
And maybe you shouldn't do the same to.
I think he's talking about personal experience.
Oh, yeah. Oh, for sure. I can relate a little bit.
Structure of these two snippets looks similar. It might just mean that you don't really understand the problem yet, and give them some time to actually like show that this is the same problem and not just accidentally similar code. And finally, I think it's just important that if that happens, if you make a mistake, it should be part of your team culture to be okay with, this abstraction is bad, we need to get rid of it. You should not only like add abstraction, but you should also delete them as part of like your healthy development process. So that means that it should be okay to leave a comment like this and say, hey, this is getting out of control. Let's spend some time to copy and paste this, and later we'll figure out what to do with it. But there's also a technical component to this. So if your dependency tree looks like this, it might actually be really challenging to inline anything, because you're like, well, I have this thing I want to inline, but like, okay, I can copy it, but there's some mutable shared state that is now being duplicated. And I need to figure out how to rewire all of those dependencies together, and it might not even be feasible, so you just give up. And I don't really have a good solution for this. What I've noticed is that for some code, you can't really avoid it. Like, for example, in the source code of React itself, we do have a problem like this. It's like we try to mutate things for you so you don't have to mutate them. So we have this all this kind of interdependencies between modules that can be a bit difficult to think about. Then what's cool about React, in my opinion, is that it lets you write apps with dependency trees that are more like this. So you have like a button component that's used from form, and like the form is used from app, and something like this. And it follows this tree shape. And we have these constraints where the data flows only in one direction, so you don't really expect things to like get weird circular. And what it means is that you're going to make mistakes, you're going to create bad abstractions, but does your technology make it easy for you to get rid of them? Because like I think with React components and some other constrained forms of dependency like management, you have this nice property where it's usually a matter of copy and pasting things in order to inline them. And so even if you make a bad decision, you can actually undo it before it gets too late. So this is something to consider in both social and technology.
That's hooks. You see that?
Yeah, that makes a lot of sense.
This was components or class components where like state was tied to a component, and then being able to have independently moving state and effects. That's hooks.
Makes sense.
So this is something to consider in both social and technology part of it. So don't repeat yourself or try. It's just one of those principles that are like probably pretty good ideas. And there are many good ideas that you might hear about as a developer and entering this industry, or even as somebody who's been doing it for recent years and then stepping outside for a few months. And we see a lot of like evangelism around those things, and that is fine. But I think it's important that when we try to explain what those things do or like why they're a good idea, we should also explain what exactly are you trading away, and which things led us to that principle or idea, and what is the kind of expiration date for those problems. Because sometimes there is some context that is assumed, and that context actually changes, but you don't realize that. And so the next generation needs to understand what exactly was traded off and why. And so my challenge for you is to pick some best practices and anti-patterns that you strongly believe are true, whether from your experience or because somebody told you or because you came up with them, and really try to break it down and deconstruct why you believe these things and what exactly is being traded away. And if you found this talk interesting, you might like these other talks. So All the Little Things by Sandy Metz is an amazing talk that goes.
Have you seen any of these?
I've not seen those, but I can definitely speak on the best practices point. I did a video on that a little bit ago called Best Practices Are a Lie, because
hot take.
Yeah, it's good to grab people in, but I was imagining, or it was going through some Twitter debates about, I think it was, should you have types at the end of your TypeScript functions or not? A ridiculous amount of discourse over that. It doesn't matter, but it harked back to something I remember from another talk that I could not find, but it was around how all of our best held beliefs aren't tied in concrete data very often. They're just felt out as X company did this strategy. Things got faster for them in some unknown metric. And then they went forward on that pattern just because that company was big. So let's adopt it in all the other companies. And you don't really think to stop and measure what the heck is going on, because you think object-oriented programming, it feels good, so it must speed up developer velocity, but no one bothers to measure velocity or speed at which code ships, because all of these things are hard to measure in a way that is replicable. So you have all these practices and you can try all of them. The only way to do it is really just try each of them, see if it works for your company, and drop it if it doesn't. And it's the dropping part that you rarely see happen. I had to go through a lot of functional programming principles at my last company, and we used it in ways that worked and ways that didn't. But we found this hammer, so we used it for every single nail in our app. We used it on the front end, on the back end for languages that aren't even functional programming based. And it just felt wrong, but we kept doing it because it's that one hammer and it feels great. It's a best practice.
What's your favorite complex FP thing that you want to rant about?
Oh, man. We used Ramda for a lot of things. That came up. This, what's showing on the screen, FPTS. I think it was too early at the time. We also used Arrow KT because we were using Kotlin on the back end. So we needed a way to push functional programming into Kotlin, which is on top of Java, which is very object-y. So this library is much more cleaned up now. This is a whole new logo and homepage. But at the time, it was tracing source code, literally starting a Slack with the maintainers of this project to understand how it works. It was very early days, and it was not worth the investment, in my opinion. But hey, I'm not the one who made the architecture decision. It was just, we've got to have this pattern. It's the best way to do things. And even if the language fights us, we're going to do it anyways.
What can I say about that? I've worked with that kind of guy.
I think that's universal. Yeah. That's what it was. That was closer to the homepage. We're trying to go through the Wayback Machine right now. But
yeah. So by the way, there's this really handy Wayback Machine Chrome extension that I use, right?
Oh, that's helpful.
You can just click oldest or newest, and it also skips past paywalls pretty regularly because Wayback Machine, people wanted to archive their content.
Interesting.
So you can use it as a one-click sort of paywall skipper. I know there are other extensions, but this is my habitual one.
Mm-hmm.
But this one's good. This one's good.
Yeah, right. This one did well on TikTok, not on Twitter. Don't know why it didn't do well on Twitter. Just
random
timing. I don't know. The Twitter algorithm is just a mess right now. I'm suddenly getting less views on videos because you don't push videos as much. I don't want to get into that. Yeah, or there's no algorithm boost anymore. So images and videos don't boost you up, but now other things are boosted up, like long form tweets. And if you have a link in your tweet, it's no longer downranked. I don't know if any of this is out of date all of a sudden, but 2 weeks ago, that was the truth. So I'm trying to follow this.
Well, structure your life such that it doesn't affect you either way.
I know. That's why.
Yeah, you're doing fantastic, man. I'm
you.
Real admirer of your video stuff. And I'm sure you have other things that you're working on. I wanted to bring this up as well. So another similar one where we don't know, but there's this very current debate right now about microservices, because essentially Amazon has been pushing microservices and serverless quite a bit. And then this guy on the Amazon Prime Video team puts out a blog post saying, serverless and microservices are overrated. We moved to a monolith. Yeah. And when I saw that tweet, I was like, this guy is like looking to get fired, because he was like very publicly on Twitter, like serverless is completely useless and blah, blah, blah. And then obviously he deleted that tweet, but it kicked off this whole debate. And I really like this podcast. If you're into technical podcasts, I think I've featured these guys on my podcast before. But they just have very knowledgeable, very casual, very funny conversations about like the current thing in tech. And they're saying exactly what you're saying, which is like anytime like Netflix or Spotify comes out with like this, here's how we do things, and everyone goes like, oh yeah, they're successful, we should do that.
Yeah. Airbnb, ESLint. Oh yeah, put that on everything.
Yeah, those lint rules are just horrible.
Yeah.
Okay, but I will make this one minimal API surface area. I want to say this is a 2015 JSConf EU talk. This is how much I know Sebastian.
Wow. Yeah, you got the timeline. Yeah, I didn't know when this talk was. Okay, 2019. That makes sense.
2019.
Because of the hooks tie-in.
No, no. Are you sure?
Oh,
No.
or for the Dan Abramov talk, it was 2019. This one I've never seen.
2014.
Yeah, that's old.
All right, that was off by 2 months.
Yeah, I finally met Sebastian in person. This is
he's great.
This is the Sebastian, right? Yeah.
I mean, I'm always like, when I'm talking to him, I don't know if like I'm like boring him or anything because he's so smart.
Yeah, I talked to him about server components because I think that's the one area I could at least sound like I know what I'm talking about on his level, because he just bootstrapped the whole thing.
All of us are just.
So I just used it to ask him questions. I didn't even give any feedback. Just like, how does this work? And we talked about circular module graphs. It was a blast. It was a blast.
Awesome. Yeah, you should record that. Okay.
Yeah, we were in a busy bar. I should have just whipped out my phone and said, "Talk about it."
I know. Talk into this microphone and be on record for.
I kept it in my backpack. Yeah, just to have at the conference.
And Cheng Liu is more low key. Most people don't know his name, but he was an original React's core team member. And he created React Motion, and he's this kind of like, humble looking guy, but like he's extremely smart. I quote him probably like 2-3 times a year watching his talks. So
okay.
Highly recommended. I'm less familiar with Sandy Metz, so this one is the one I haven't watched. Cool. I think we may have finished that talk. What do you think? Anything else that you want to discuss?
I don't think so. And my only comments would be related to other ones on the list, because I tried going generally, because I curated some of the videos that we're checking out, but I was starting with API design practices, and it ended up just being clips about abstraction for all of them. It just ends up that way, where if you're talking about design, you end up talking about abstraction, no matter what it is. So we've ended up there. Yeah.
Cool. So the next one we'll do Red Shaky, but I think this will be a good place to end the first episode.
Yeah.
All right. Ending broadcast. Bye.